Good afternoon all. Today we are going to discuss about introduction to formal languages and automata theory. So before getting to the topic, first we have to know what is automata theory. So here theory represents study. So automata represents one kind of abstract machines. So in automata theory, we are going to discuss about study of abstract machines. So we have to discuss about in detail about abstract machines in automata theory. So here abstract machine represents what? Abstract machine represents the device which is useful only for computation purpose. So the device which is useful only for computation purpose is called abstract machines. So in automata theory, we are going to discuss about the study of abstract machines. So the automata theory give the details about models for the abstract machines. So automata theory, we can also say that theory of computation. So computation represents have three steps. First we have to get the input, we have to do the process on that input, and we have to get the results. So the computation involves three processes. So executing, it also called executing an algorithm. So it takes some input, perform some operations on that input and provide the output as a result. So the theory of computation provides various basic ideas and models for the computation purpose. So there are our theory of computation or automata theory provides various abstract models for the computation purpose. There are these classifications, it provides various abstract models. It is classified into two categories. First one is restricted model, another one is universal model. The example for the restricted model is finite automata, and example for universal model is Turing machines. So where this theory of computation will be useful means it is useful in the design of compilers, then it is useful in the robotics field, then useful in the field of artificial intelligence and knowledge engineering. So here automata represents any kind of machine. So it is useful for performing computation. So there are several kinds of abstract machines are available. First one is finite automata, next one is push down automata, and linear bounded automata, and Turing machines. The finite automata, this abstract machine where it is useful means it is useful in the design of lexical analysis, which is the first phase of a compiler. Next one, it is useful in the design of text editors, then it is useful in the design of spell checkers and combinational and sequential circuits. Then another kind of abstract machine is push down automata. It is useful in the design of syntax analysis, which is the second phase of a compiler. Next, implementation of stack applications. It's like identifying or checking equivalence of parentheses. Next, Tower of Hanoi problem. And then another abstract machine is linear bounded automata. It is useful in genetic programming and semantic analysis, which is the phase of the compiler. Then another abstract machine is Turing machines. It is applied in neural networks and artificial intelligence problem, robotics, and recursive problem solving. So first abstract machine is finite automata. So we are going to discuss what is finite automata. So all these abstract machines are accepting some languages or producing some languages. So what is mean by language? The language gives the language is a collection of strings. These strings are accepted by this kind of abstract machines. This abstract machine generates the set of strings. That strings collectively together called languages. This finite automata provide the language as regular language. That is, the language accepted by the finite automata machine is called regular language. So this one model is developed by Scott Robin in the year of 1950. So this abstract machine has no memory, or it has limited memory. It only accept the input and process the input and produce whether the given input is valid or not. So it is useful in the decision making problems. So we'll take one real-time example. Consider these digital lights or digital lights. This now the digital light state is on. Some other state of this digital light is off. So when the light move from one state to another state, will give some input. So what kind of input we can give? We can switch off the light. So while switch off, the power will cut. Then it move to another state. So we can represent the finite automata in the model of diagrams. So the finite automata consists of set of states. So then for each state we can give some inputs. So from that one state it move to another state with the help of those inputs. So here the finite automata have initially off state. After giving input it move to on state. So after giving input to on state it move to off state. So this edges represents the transition between the states. So there are two kinds of finite automata are available. First one is deterministic finite automata. Next one is non-deterministic finite automata. So in deterministic finite automata, for each input symbol, we can have only one transition out of each state. That is, for example, if I am giving one input to the particular state, it move to only one state, not more than one state at a time. So in non-deterministic finite automata, for each input symbol, it can move to more than one state at a time. So it is possible only in non-deterministic finite automata. So now we are going to discuss about model of finite automata. So the in finite automata model, there are three components are available. One is input tape, next one is tape head, next one is finite control. So the input tape is useful for storing the input. It consists of sequence of cells. Each cell is capable of holding only one input symbol at a time. Then the tape head is initially pointing to the first input symbol in that tape. For each step it moves to next input symbol. After processing one input symbol, it moves to the next symbol. Then here finite another component is finite control. It acts as a CPU. So it takes input as current state and current input symbol. Based on this current state and current input symbol, it will decide what is the next state. So this finite automata we can represent in two ways, by using transition diagrams or by using transition table. So here the transition diagram has some notations. So in this circle symbol with the arrow represents the start state. Then this edges represents the transitions from one state to another state. Then label of the states represents the input symbol. Then double circle represents the final state. So the process starts with the initial state. Then after getting the input, it may move to another state or in the same state. So if we are giving one input at means after processing the input, the machine will reach the final state, means the given input is accepted or the given input is valid. If not able to reach the final state, means the input is not accepted, otherwise the input is not valid. So the same we can represent in the form of diagrams. So here we have 3 states, Q0, Q1 and Q2. So for what are the input symbols used in this finite automata? 0 and 1. For Q0, if you are giving 0 as input mode, means it moved to Q2 state. For state Q0, if you are giving 1 as input mode, means it moved to state Q0. If for Q1 if we are giving state 0 as input mode, it moves to Q1 state. For Q1 we are giving 1 as input means it moves to Q1 state. So like this we can represent in the form of transition table. So here this arrow represents the starting state, this star represents the final state of that finite automata. So this finite automata useful in the design of compilers, then useful in the design of text editors, then pattern matching, then file searching program, then text processing. So what is the drawback of this finite automata means? It can accept only simple languages, it has limited memory, it is useful only in the decision making problem, it's not for computation purpose. Thank you.